Good morning and welcome to our live training session for AWS Associate level. My name is Satya and I will be the training facilitator. I'm glad you found this training material here. All of my technical training videos are freely accessible on this website. Kindly subscribe to this channel if you have not done it, and to get the up-to-date notification alerts, please click on the notification icon. Also, please note the download links for the step-by-step lab exercise notes are provided in the description. We are on day 4. Today's class will cover a variety of important topics. The agenda for today's class is displayed on your screen. So the first topic for today is the cloud delivery models. In other words, the categories of cloud delivery models. So it all depends on how a service provider provides their cloud services to the clients. So that is all about the cloud delivery model. To start with, we have 3 base cloud delivery models. IaaS, that is infrastructure as a service, platform as a service, and software as a service. This cloud delivery model, it is all about a particular pre-packaged combination of IT resources offered by cloud service providers. So that is what we are referring to back and forth as a cloud delivery model or cloud categories, the cloud categories. So let us understand the traditional way of managing our on-premises data center with cloud delivery models such as infrastructure as a service, platform as a service, and software as a service. So here in the pictorial presentation, we can see 4 blocks. Onto the extreme side, we have on-premises. That is our traditional data center, where we manage all the resources. We own the infrastructure, the land and building, the servers, the power supply, the air conditioning, the security, human resources, the engineers. We own each and every of them. That is on-premises data center. We have invested, we are managing, we are taking care. Okay. The next 3 models, that is infrastructure as a service, platform as a service, software as a service, that falls under off-premises cloud, that is a data center. It is famously referred to as the cloud data centers. So often on-premises data centers are what we own. In case of cloud deployment, the service provider will manage all these infrastructures for us. So you as a customer will pay the rental charges and use it. You do not own the responsibility of managing these resources, as we just discussed. So it is like choosing between owning a car and renting a car for your day-to-day use. To own a car, first we need to decide the car that fits in our budget, then arrange for a finance or loan, further arrange for parking place, manage the fuel expenses, insurance, regular maintenance, monthly maintenance, servicing, and finally drive the car by yourself or hire a driver, car driver, correct? So this is owning a car is just like you own your own data center, that is on-premises data center. There are so many hassles, right? Owning a car, it is just like owning our on-premises data center, as I just said. So the bottom line is here, you're the boss and you will manage everything end to end. So opposite to that is renting a car. It is like our cloud infrastructure. Renting a car is something like you rent a car from Ola or Uber. So in our today's discussion, cloud services, that is off-premises data centers, are something like renting a service from the service provider. Here, you own a car for a given period of time, and you enjoy all the benefits owning a car. That is, you are renting a car for a given period of time, and you will enjoy all the benefits of owning a car, but you do not take the ownership of managing the recurring expenses. So here, the owner of the car, it could be either Ola or Uber in our example, will do everything on behalf of you, and you will pay only for your travel expenses. And that too, you know the expenses or the estimation well in advance, even before you booking a car, right? The same thing happens even with our cloud technology. Once you create your EC2 instance, a virtual machine, once you deploy your resources, you know very well in advance, you know the estimation, how much you need to spend for a given period of time. So this is what the cloud computing offers. Here, the service providers such as AWS, Azure, GCP, that is Google platform, Google Cloud Platform, will do all the investments, manage their resources and infrastructures. We, being the end user or customer, we will only be charged for the time that we actually use these resources or the services. So this particular approach is called pay-as-you-go model. Just take our previous lab exercises as example. The virtual machines, whatever we have created, we do not own them, right? Since we are learning AWS and we were managing our lab exercise in AWS environment, all those resources are managed by Amazon Web Services. We just created our AWS free user account, logged in, spinned off a virtual machine, used it and decommissioned it. We have deleted that virtual machine once we are done with that work. And for that, are we paying anything? Yes, we are paying from our free service, a free support, that is a free user service available from AWS. Once you cross that limit, you will be charged. So this makes sense, right? We save a lot of money. So there is no upfront investment. So who is using these cloud services? Almost everyone, my friends. From a roadside street vendor to big corporate companies, all of us, we use these cloud services. Can you guess how a street vendor or a shopkeeper is using these cloud services? Yes, let's just touch upon that and move on to the topic, other topics. Just take the example of Paytm, BharatPay, Google Pay, UPI, QR code. There are so many payment systems, right? So these are all the service providers offering online payment service to the vendors, to the merchants. So here, the vendor opens his or her online account with this service provider, and that account is linked to their bank account. So this vendor does not know anything about the cloud, the internet, the storage, mobile data connection, payment gateway, etc., etc. So, but the service provider, we just spoke about Paytm, BharatPay, Google Pay, whoever, make sure that all these backend work is taken care. So here, the vendor is paying nominal transaction fee towards the service charges to get online payment system into their bank account, the money getting credited into their account. So if you walk into any shopkeeper vendor, when you scan their QR code, make a payment, that money gets into the particular vendor's account directly, deducting a small portion of money towards the service charges. That is what the service charge charged by this service providers, Paytm, BharatPay, or Google Pay. Similarly, even in the cloud, when you are using the cloud services, AWS, Azure, Google Pay, IBM, whoever the service provider, the services, whatever you are charging, you are renting these services, the infrastructure. You are least bothered about the investment, the caretaking of this backend system, which is running, which is supporting you, providing the services. The service provider, he will take care. So now we got a broad idea about what is cloud and how it is different from our on-premises data center. So the use of cloud service is widespread, and different users use them for various objectives. So let us compare the on-premises data center with the traditional base cloud delivery models that are available. Apart from the three what has been mentioned on the screen, infrastructure as a service, platform as a service, software as a service, there are other cloud delivery models also available, though they are not that popular. So in the first case, in the pictorial presentation, what you see on-premises data center, here, all these services, the applications, runtime, middleware, operating system, the virtualization, server, storage, networking, everything has to be managed and taken care by the owner. Here, the owner is yourself. So you own all these infrastructure. You will have to have the manpower. You will have to have all the key required things to manage. The same thing if you move on to IaaS, infrastructure as a service. Here, the service provider will provide you the virtualization. The service provider will provide you the servers, storage, networking, and the remaining thing you will have to manage. What is that remaining thing? The operating system, middleware, runtime, data, and applications. Can someone tell me where do we see this infrastructure as a service? Remember our lab exercise, whatever we performed, the EC2, the virtual machine, the Linux virtual machine or the Windows virtual machine, what we have created, that falls under this category, infrastructure as a service. Here, when we have created the virtual machine, Amazon Web Services provided these four support: virtualization, servers, storage, that is hardware, hard disk, networking. So what we did, we have taken Microsoft Windows operating system we have installed. During the installation, there were so many middleware, runtime libraries got installed. Where there were data which is created in the backend. Applications. Remember, we have downloaded the IIS server. That's an application software. We have installed the application software. We have configured. We have hosted our web page. All these services, as a user, you and me, we are responsible. We need to manage these resources. So Amazon is only responsible with the four services, and anything and everything happens to that, they are responsible. They will take the ownership. So the rest remains on our shoulder. That is infrastructure as a service. The next type of cloud delivery model is platform as a service. Here, the service provider could be AWS, Azure, Google Cloud, IBM, Alibaba Cloud. There are over 800 plus cloud service providers to take their name. Okay, so here from the last 8 services, the runtime, middleware, operating system, virtualization, servers, storage, networking, these services are managed by your cloud service provider. In our case, it is AWS. So we, as a user, we will manage only the applications and the data. Our ownership is only limited to applications and the data. The application software is what you install, maybe the databases. You will have to manage only those two. The remaining everything is taken care by the service provider. So the last but not least is the software as a service. Here, everything is provided by the service provider, from applications to networking. Everything is managed, and the whole and sole responsibility, the ownership is there on the service provider. So what does the user do? User just logs in, they create their data, and they save it or they share it. For example, our email system. So email, everything is taken care by the vendor. It could be our Gmail or Microsoft Outlook. It could be any email platform, just to take an example. So as a service provider, in case of Gmail, the Google company, they take the complete ownership, correct? All the tools, everything is provided. All you need to do as a user is create your user account, log into that Gmail account, create your email, check your emails, send and receive. That's it, correct? Similarly, our WhatsApp, Telegram channel, you own nothing. You just create your account, you add up your contacts, you will start communicating. That is what the software as a service. So these are all the basic cloud delivery models are available. Apart from that, there are several other cloud delivery models are available that we will touch upon. Before that, let us have in-depth view of what are these base cloud delivery models, IaaS, PaaS, and SaaS. Let us move on to the next slide. So here we have the IaaS, that is infrastructure as a service. What is this all about? It is an instant computing infrastructure provisioned and managed over the internet. A cloud service provider such as AWS, Azure, GCP manages their infrastructure, while as a user, you purchase, install, configure, and manage your own software like operating system, middleware, runtime, data, and the applications. So this particular example fits very well with our EC2 instances, the virtual machines, what we have created. So it is an IaaS type of delivery model. So an IaaS environment's main goal is to give cloud users extensive control and responsibility for the configuration and use of the system. So they provide the bare metal hardware virtually, and you use those bare metal hardware and use it as per your requirement. So the IT resources provided by infrastructure as a service are generally not pre-configured. That's correct, right? The virtual machine, what we are picking up, what we are creating, it is not at all configured right from the base operating system. We will have to manage, we'll have to take care of that, everything. So thereby placing the administrative responsibility directly upon the cloud consumer. So as a learner, when we are creating our lab exercises for our practice, we are the consumer. Maybe we are getting, we are not paying for it. The charges are getting deducted from our free usage account, but still there is some charge, correct? Directly we are not paying. We are getting freebies from Amazon to use it for 750 hours every month. So out of which it gets deducted. So here in the pictorial presentation, you can see as a customer, what are the things that you need to manage, and as a service provider, what are all the things the AWS they manage. Here you can see AWS manages networking, edge location, availability zones, regions, databases, storages, and the compute. So these are all the responsibility of the service provider. In our case, it is AWS. Suppose you are learning Azure, it is the responsibility of Azure, these things. So as a customer, as an end user, we are responsible to manage our operating systems, the network, firewall settings. So today we will learn about firewall. What is a firewall? Application management, the platform, the customer data, user data, all these things we will have to manage, including the client data encryption, the server side encryption, network traffic, managing them, load balancing, everything as a customer, as an end user, we will have to manage. So this is all about one of the cloud delivery model, that is IaaS, infrastructure as a service. Please give your kind attention. This is the basic foundation, fundamental thing in cloud vertical. Unless you know these concepts very well, you will not be able to understand, you'll not be able to get along with the cloud technology. So the next comes the platform as a service. So platform as a service is a cloud computing model, once again, in which cloud vendors provide hardware and the software tools such as the source code editor, debugger, and other essential tools to the developers to use over the internet to build their applications. Here, some of the popular cloud service providers are AWS, Azure, GCP, IBM, Oracle. They all manage both hardware as well as the software, except the applications data that are managed by the users. Say, for example, if you take Oracle database, Oracle, they provide their hardware and the database. You log into their system and you will start managing your data, right? That is what it is. Similarly, you take Google platform, the Google email. So they provide both hardware and software. You will log in and you will create your emails. You will send emails. You will receive emails. You will add contacts. That's what. So some of the popular examples for PaaS are .NET, Java, Ruby, Python, Go language, JSON, YAML. They're all the programming languages. They provide both hardware and the software. So since all of them, they have moved into cloud vertical, you will log into their cloud infrastructure. You will start writing the Python code maybe. Okay, that code you will compile it and you will use it either into your traditional on-premises data center or into your laptop or maybe into the cloud itself. So this is another type of a cloud delivery model, that is a PaaS. So here, once again, you can see the responsibilities, roles and responsibilities are increased from the service provider side because they need to manage, including the operating system, network configuration, platform application management, apart from the traditional other standard services which they were managing in infrastructure as a service. There are additional add-on responsibilities came on to the service provider. So this is how the PaaS, that is platform as a service model, works. Let's move on to the next one, where it is software as a service. So here in software as a service, it is a type of delivery, delivering the applications or the internet as a service. So instead of installing and managing the softwares in your PC, the user will simply access the software via the internet, freeing himself from managing the complex software and the hardware. So some of the top SAS service providers are Oracle, SAP, Cobweb, including Microsoft, Akamai Technologies, Adobe. Nowadays, Adobe, Microsoft, Office 365, everything is available online, right? You will not be installing any of those application softwares in your computer, in your laptop. You have the login email ID already. You will log into that and you will create your documents, spreadsheets, PPT presentations. So everything is available in the internet, in the cloud. Wherever you move, all you need to do is you need to have a device with an internet connection and you are ready to go. You can access all your data. It is centrally available. Earlier, what happens? You need to carry your laptop, the physical device, or the pen drive, store all the documents, the PPT presentations that are needed, spreadsheets. You need to connect to another computer, a device, then you need to start using. Now, no, nothing. Everything is centralized and it is available. It is just like our email. Yeah, you are whether here in your native or in out of the country. All you need to do is you need to have a PC with internet connection or a handheld device with the internet connection. You can log in and access your email, right? Same thing with our Telegram channel, WhatsApp. They're all falling under the category of software as a service. So let us try to understand what are the different types of other services available apart from these are the base delivery models, that is infrastructure as a service, platform as a service, and a software as a service. Apart from that, there are many other types of services are offered by these service providers. Let us have a quick look. What are they? Okay, here we go. You have the details on your screen. The other types of services are SaaS, we have already touched upon, FaaS, function as a service, database as a service, storage as a service, security as a service, communication as a service, testing as a service. So who are all the service providers? Here, let us start from the beginning. IaaS, infrastructure as a service. Who provides this facility? Amazon Web Services, which we are already well aware of. EC2 is one of that core service available in AWS. Similarly, Rackspace, another company, is offering. OpenStack is providing. Google Compute Engine, they are providing Apache Cloud Stack. There are many service providers are offering these services. Similarly, if you take next is the storage as a service. Storage, you can see you have OneDrive, correct? OneDrive is the place where we store our storages, correct? And Google Drive, G Drive. Google Drive is another one. In Amazon, we have something called S3, Amazon S3 Simple Storage Service. Next, we have Dropbox, iCloud. This is from Apple. We have many other cloud service providers who are offering this storage as a service facility, delivery model. Next comes the platform as a service. Here we have many other service providers, Microsoft Azure, Salesforce, AWS. Once again, most of these service providers, they offer more than one type of service. That's why you can repeatedly see the same name in almost all the places. Next, the database as a service. We have DynamoDB. This is from my AWS. Once again, from Oracle database they provide in their cloud. We have one more called Cockroach database. These are all very upcoming recent database models, delivery models. SQL is available from Microsoft Azure. We have cloud data store. There are many database online services are available. Next comes the function as a service. You can see some of the function as a service. It is available from Apache. It is available once again from AWS. We have a service function as a service. Each and every model, delivery model, is meant for a specific task or for specific purpose. The last but not least is the software as a service. We are all well aware of using Microsoft Office 365, G Suite, Google Suite, Salesforce, Zendesk. So these are some of the popular software as a service delivery models available from the service provider. I hope by now we have touched upon in detail, in depth about the base cloud delivery models, apart from some of the other unpopular service delivery models that are available. With this, we'll be concluding the cloud delivery model topic. We'll move on to other topics that are very important and a few lab exercises we are targeting to perform in today's class. In that category is what we have is the security groups, inbound rules, and outbound rules. What is all about security groups? We have already worked upon this, but we have not performed any elaborative lab exercises. We did not explore much of these things. That's why this topic has been lined up to understand what all about a security group. A security group acts as a virtual firewall for our EC2 instances, that is for our virtual machines, to control the incoming and outgoing web traffic. So every security group works in a similar fashion to a firewall, as it carries a set of rules that filter traffic comes in and traffic goes out from your virtual machines in AWS environment or EC2 instances. These type of security groups are, of course, available with each and every service provider. The best example for the security group is, remember, while creating the virtual machine, we have enabled the RDP port for Windows virtual machine. Similarly, the SSH port number 22, we have enabled for our Linux virtual machine. Similarly, we have enabled port number 80, HTTP port, to have a web server to access the web pages from external, from internet, correct? These are all the security groups. So we will touch upon that in today's lab exercise to understand better. So here we have two types of a firewall available, an inbound and outbound. Inbound firewall rule controls the incoming traffic to your EC2 instance or virtual machine. The port number 3389, that is RDP port, port number 22 SSH port in Linux machine, what we have set up, that is what the inbound firewall rule. So outbound firewall rule controls the outgoing traffic from your EC2 instance or virtual machine. So you might have come across, if you have worked in some corporate companies, some of the web pages like Facebook is blocked, Twitter is blocked, correct? So you will not be able to open these web pages from your office network because the outbound rule has been set to block those websites permanently. Okay, that is what the outbound rule. So inbound traffic originates from outside the network, while outbound traffic originates inside the network. That is what we have discussed about. So when you launch an instance, you can specify one or more security groups and add inbound and outbound rules to each security group that allow the traffic to or traffic from its associated instances. So we will touch upon all these things in the lab exercise to understand better. So further, we have the topic of ports. What is all about a port? In a computer networking, a port is a communication endpoint. At the software level, a port is a logical construct that identifies a specific process or a type of network service. The port number, whatever we have assigned in our previous lab, that is port number 3389 for RDP, a remote desktop protocol. Similarly, port number 22 SSH, port number 80 for HTTP. They're all software level ports. So we have two types of communication transfer protocols are available, TCP and UDP. These are the most common transport protocols that are available. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So to be precise, there are around 65,535 possible port numbers are available, from port number 1 to port number 65,535. Each port number is set for a specific purpose. So to begin with, we have ICMP port. This is used for echo request. Remember, we used the ping command to check the IP address of a website yesterday. Actually, ping command is not meant for checking the IP address. To check the communication, is the communication happening from the source to the destination? To check that, we use the ping command. So the ping command uses the ICMP protocol. Next, we have the port number 2021 used for FTP protocol. Port number 22, we are already well versed with. We have used it for SSH in Linux virtual machines. Similarly, we have port number 80, which is HTTP port. HTTP, yes, there is another secured protocol, transmission protocol available for that. The port number is 443. So in our lab exercises, we have touched upon the port number 3389, that is RDP port. That is for remote desktop control, to remote desktop access. If any of these port numbers are not enabled, you will not have access to that virtual machine. So please note, make a note, by default, I repeat, by default, all the servers will not have any of these ports enabled. By default, all these 65,535 port numbers which are available are disabled. So unless you need it, you need to enable these port numbers. Only then you will be able to access. In one of our today's lab, we will touch upon this as well. So by disabling a particular port, what happened? By enabling, what happens? We will touch upon those things. So continuation to these ports, we have another very important topic called firewall. So what is all about a firewall? A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. That is what the security rule that we have set, enable a particular port number or disable it. A firewall typically establishes a barrier between a trusted network and an untrusted network, such as the internet. The internet traffic cannot be trusted. All malware, spyware, hacking, all these things happens through internet only, right? So that's what it is. Internet is an untrusted network. What is trusted network? Our local area network, local LAN. Within our organization, within our premises, we have the network. That is the trusted network. To make it still more simpler, the broadband connection, what you have at your home, the router that shares all the internet traffic with all the handheld devices, what you have, it could be laptop, desktop, your mobile phone, correct? So that is a trusted network. You have username and password set, right? You cannot log into your neighbor's internet, though which is visible. The moment you go and open your wireless network on your mobile or laptop, you will see all the networks available, including your neighbor's network is also shown there. But if you try to log in, if you do not know the password, you'll not be able to log in back, right? That is what the trusted network. So firewalls can either be a software or hardware based. A software firewall is a program installed on each computer and regulates traffic through port numbers and the application softwares. While a physical firewall, it is a piece of hardware equipment installed between your network and the gateway. So this is all about the firewall. These topics are very important because based on these things only we'll be able to understand how the setup, what we are going to create, the virtual machines, how are we going to configure, how are we going to control the network traffic, all of them are dependent on this. So continuation to this topic, we have another important topic, which is called a ping. The ping command, it is a network command. So the ping command is a very common method for troubleshooting the accessibility of devices. What does that mean? If you need to check whether the connection is working, whether you're able to handshake with that particular device, whether you're able to send hi message, receive that message back stating that, yes, I'm able to hear you. That's what we did at the beginning of the today's class, right? I was checking, am I audible, guys? So please let me know. That's what it is. It is the ping. So it uses a series of Internet Control Messaging Protocol, ICMP. ICMP, the abbreviation is Internet Control Messaging Protocol. It uses ICMP echo message request. It sends a continuous, a consistent hi message. Hi, are you there? Mic testing 1, 2, 3, something like that. So other side, the device, the server will be able to reciprocate. Okay, if that server is willing to respond back, it will send a reply back. Echo request, it will a reply message it will send saying that, hi buddy, yes, I'm able to hear you. Only then the communication is established. Sometimes you might have come across, right? You will dial a friend, dial a contact from your phone. You keep talking, the other side, they're not responding. They're not able to hear you back. That means the communication is not established. Though the call got connected, you're not able, there is a one-way traffic, one-way communication. The other person is not able to listen or respond. Why all those things? Even while we are talking, while you're communicating, talking to your family members or friends, sometimes you will ask something, the other person is not at all responding back. Okay, maybe that person either chose not to respond, or he did not hear what you said, or he or she did not understand what actually you were trying to say. So the same thing happens even in our computer world also. When you try to open Google, when you try to open Facebook, Twitter, Instagram, sometimes you'll not be able to get connect, right, to that computer, to that server. You will say website, you will see the message, website not accessible, or 404 error, 502, 501 error, correct? That is what exactly the other side of the computer where you want to communicate, interact, is not responding. So how to check that? We will check those things with the ping command to analyze what exactly the problem, where it is going wrong. So what exactly the purpose of this ping command? It is meant for to check whether a remote host is active or inactive. The round trip delay in communicating with the host is establishing. Is there a packet loss? What is a packet? Packet is what we are referring to in the journal. We are referring to as network packets. You might have observed, right, while downloading some software or videos from YouTube or from the internet, it will be showing the size, the total size, the file size which is getting downloaded and the approximate time left to download. It is referring to the packets that are getting downloaded into your computer. Each packet has got a certain size. So that is what it is referring to, the packet. When we say the packet loss, some of the data which is getting downloaded, it is not able to download. It is getting disconnected. So that is what the packet loss. So with the ping command, we'll be able to analyze these things. So the ping command first sends an echo request packet to an address. Maybe like in our example, we'll take Google web server. It will send a hi message. This hi message is a packet. Then waits for the reply from Google web server. So Google web server receives this communication hi message and it will reply back to the source computer, that is your computer from where you executed this ping command. That is when the ping is successful. If the echo request gets to the destination and the destination is able to get an echo reply back to the source within a predetermined time, it should happen within a stipulated time frame. If I say hi to you, if you reply back after 5 hours, what happens? It's of no use, right? It should be spontaneous. It should be instant, or else we will move on. So that is what it is. So here in Cisco routers, the general time set is 2 seconds. So if you send a hi message or if you're trying to open a Google web page or some web page, the web browser will wait for 2 seconds. If there is no response, then the web server will, then your web browser will give a message stating that, sorry, buddy, this web page is not accessible. The server is not giving a response. This is all about the ping command. So in our today's theoretical class, we have one last topic. We'll touch upon that and move on to lab exercise. The most important topic in today's class is the Bastion host. We are going to perform a lab exercise on this topic as well. What is all about a Bastion host? A Bastion host is a special purpose server or an instance virtual machine in a network specifically designed and configured to withstand attacks like DDoS. DDoS stands for distributed denial of service, ransomware attack, virus attack, spyware, hacking. So to withstand our corporate main server from these kind of attacks, we will, in between our corporate network and the user, we will place a Bastion host. It is like a dummy server that will not have any kind of application software database. No information is provided. The purpose of this Bastion host is just to take the incoming traffic and forward that incoming traffic to the corporate server, the most secured server. So this instance generally hosts a single application, for example, a proxy server, and all other services are remote or limited to reduce the threat to the computer, the main server. So a server instance is designed to be primary access point from the internet and acts as a proxy to your other EC2 or virtual machines. So this Bastion host is also referred to as a jump server. It acts as a bridge between two trusted networks. A Bastion host always sits outside your network, that has a public IP address. Please remember this. A bastion host will always have a public IP address, typically accessed using SSH or RDP. So once the remote connectivity is established with the bastion host, then it acts as a jump server, allowing you, the user, to log into the main core virtual machine, that is the corporate network, that is in a private network where there is no public IP address. Okay, so in this pictorial presentation, you can see here we are the bastion host users. We are connecting to this computer, bastion host, with through the internet. So from here, we are connecting to this bastion host. This has got the public IP address. You can see the public IP address is provided. So that is how we are able to log in. And from here, we will log into our corporate network that has got only the private IP address. There is no public IP address. So from here to here, if you, let me erase this. So from the internet, if the user want to connect directly from here to here, it is not at all possible because there is no public IP address enabled. So for this computer, if you want to connect, you can connect only from this computer because both these computers has got common private subnet, common private IP address that we will explore in today's lab exercise. So only then you will be able to log in from here. Does it mean one employee is from Wipro, another employee is from Infosys? Can they connect to their servers between themselves? No, because both of them are having independent different subnet. So you'll not be able to communicate each other. So, all right, friends, so we have reached at today's end of a theoretical class. Let's move on to the lab exercise. Okay, so we'll perform a couple of lab exercises today to explore more. What are all the lab exercises? Here are they. We'll first set up an inbound rule in a Linux environment. Similarly, create a environment in Windows, and finally the bastion host. All right, we'll perform all these things in the lab exercise. So thank you so much. We'll move on to the lab exercise now.